So one thing I want to talk about here is just a couple of collection of useful little tricks that often come up when you're doing integrals. So first of all, for the very first integral of 1 over 4 minus 3x dx. So what integral does this look like? This looks like 1 over x. So what should you substitute? U equals 4 minus 3x. And then basically you get the integral of ln u, the integral of 1 over u, which is just ln u. Okay, and then of course you have to keep track, you have to find your du, you have to keep track of the constants. That's the first thing. Second thing, what about this next one, the integral of 2 over 1 plus 4x squared? What does this look like? Right, this looks like 1 over 1 plus x squared, the integral of which would be arctan. Okay? But in order to make it look like that, we're going to do a substitution. What substitution should we do? U equals what? U is not 4x. Because then when you square it, what would happen? Yeah. U has to be 2x. Because, think of it this way. What do you want u squared to be? You want u squared to replace 4x squared, which means u should be 2x. Okay? So this is a sort of approach to doing u substitutions in these relatively straightforward problems where the big trick is just keep track of the constants. And this reminds you that you can just sort of push constants around and push linear terms around just by making u substitutions to make the integral look like the way that you want it to look. Okay, so does that make sense?
Yeah, I was trying to do that with one of the homework questions.
So right, so it's important to keep in mind that these are very simple integrals. If your integral is more complicated and you try a substitution, if it works, great. If it doesn't work, you gotta try something else. Okay. So now I want to sort of go through, so it's all in one place, the algebra tricks that we've used or commonly used when we're doing integrals. So the first one, the easiest one, is just expand. So if you something like x times x minus 1, don't look for a u or du, just multiply it out, and then you get something very easy to integrate. That's number one. They should all be that easy, right? Number 2, complete the square. So if the integral of 1 over x squared plus 2x plus 2.
You add 2.
Just complete the square. So here's mentally how I completed the square. I said take that 2 and split it up into a plus 1 plus 1. And then once you do that, you have x squared plus 2x plus 1. I mean, you could write it down however you like, but the bottom line is you wind up with x squared plus 2x plus 1 and then a plus 1, which then becomes x plus 1 squared plus 1. And then what's this going to be? This is just going to be arctan of x plus 1. Du equals dx if you do the u sub, so there's no constant to worry about. This is a problem also. So first of all, oops. Okay. What's the general technique that's suggested that we do on this problem?
Complete the square.
Right. So we're going to complete the square, yes. And what's that going to help us do?
Like a trig. Eliminate the
And then we're going to do a trig sub, which will help us eliminate the square root. Right. So in this case, complete the square is like a very specific thing that we know as a step in a bigger process. So how do you complete the square here? So first of all, you've got a negative x squared, which when you're completing the square, you know you don't want. So we have to rewrite this. I did it a different way. Let me do it now. Okay. Yeah. So now we've got x squared as a lead term, which is good, and that tells us exactly, now we can figure out what we need to add in. So this is x squared minus 2x. So to complete the square, we're going to need a plus 1. But since it's inside the parentheses, it's really a minus 1. So to even that out, you need a plus 1. So this is now, right, and I'm going to put that 1 in front. So it's really this. And now with a quick, I call it a mental substitution, u equals x minus 1, we know that this is just arcsine. Plus c. Okay. Now we get to two of what I think are two techniques of using algebra, which I think are A, two of the most important, and B, two of the trickiest, because it's not always obvious. First one, break up a fraction. Integral of 1 plus 2x over 1 plus x squared dx. Now your first instinct is, oh, let's try u sub, u equals 1 plus x squared, but that doesn't quite work. Then you might think, oh, I've got a polynomial divided by a polynomial. I should do partial fractions. Problem is, denominator does not factor. So we have to use a clever algebra trick. And the clever algebra trick, spoiler already alerted, you have to split it up. And if you split it up, I think you immediately see these are two easy integrals. The first integral is just arctan x. And how do you do the second integral?
U equals x squared.
U substitution, u equals 1 plus x squared. And your du is sitting right there on top. You integrate that and you get ln of 1 plus x squared. Okay. So this algebra trick is something that you should have in the back of your mind as one of your tools. In addition to all the, as we might call them, like the headline techniques. Okay. Another algebra trick. And this one's even trickier because there's no reason to think of it except that I'm about to tell you about it right now. Add and subtract in a fraction numerator, then split up the fraction. What do I mean by that? Okay. Integral of 2x over x squared plus 2x plus 1. So again, the first thing you might think of is, let's look for a quick u substitution. U equals x squared plus 2x plus 1. Du equals 2x plus 2. So close. But we can make it work. How do we make it work? What's missing right now? What's missing is a 2. So you know what? It turns out that what works is if you just stick it in there. Plus 2 minus 2. And then after you do that, you can now split up the fraction. And so the first one is now the u sub that we wanted. And what about the second one? How do we do that second integral that we've created?
Take out the 2.
Yeah, this is a simple. This is a mental u substitution, as I like to say. That 2 is just a constant, and what you've really got is u to the negative 2. So that's and du is dx. So that's very easy to do. Okay. So this last one, It's slick, right? It seems to be magical. Okay. So now that we know, well, yes. So this is a trick or a technique that you should only think of as like a last resort when you want to think of what kind of out of left field tricks you can do on a problem.